Today we're going to be talking about geometric mean. Geometric mean. Geometric mean between two possible values, a and b, is the number x such that a over x is equal to x over b. So I believe these are called, a and b are called the extremes, and the x are called the means. That's not something I want you to know. I just want to give some context. So another way of saying that is if we cross multiply, we get x squared equals ab. So therefore, x equals the square root of a times b. Okay, find the geometric mean between these two values. So for a, you have x equals the square root of 2 times 50. So x equals the square root of 100, and we simplify that 100 to be 10. So finding the geometric mean between 8 and 10, x equals the square root of 8 times 10, square root of 80. Now I want this in simplest radical form. So break 80 down into perfect squares. Breaking 80 down into perfect squares is 16 times 5. And I can take the square root of 16 times by the square root of 5 and get 4 root 5. Okay, we have a theorem that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. If CD is the altitude to the hypotenuse AB of a right triangle, so this right triangle here, the big right triangle, is similar to these two triangles and to the ones, and also these two triangles are similar to each other. So what that means is triangle ABC is similar to two other triangles. And half the battle, I'm not going to lie, is figuring out those triangles. So remember, corresponding parts are going to be placed in the same spot. C is where my right angle is. So in this red triangle, D is where my right angle is. So that goes last. And then D is also going to go last for the other one, for the blue triangle. Okay, so let's figure out the other corresponding pieces. So in the red triangle, it has angle A. The black triangle also has angle A. That's listed first, so that's going to go first. So I go A, C, D. For the blue triangle, the common angle that both the big triangle and the smaller blue triangle have is B. So B is listed second. So I've listed B, I've listed D, so the last corresponding side is C. So again, look at it when you're trying to figure out these triangles. And let me change this so that you can see it by the colors. Okay, look at triangle ABC, the big one, and figure out where the right angle is. My right angle is at C. So in the other triangles, when you break those apart, figure out where the placement of the right angle is in your corresponding angles. And then figure out where the other common angle is listed, and then fill in from there. Okay, so write a similarity statement. So again, we're writing a similarity statement. And we have one triangle similar to a triangle that's kind of highlighted in red, and that's going to be similar to a triangle that's highlighted in blue. So the big main triangle is EFG. Okay, EFG. And then I have a blue triangle. I'm sorry, I'll do the red triangle first. So I'm going to break down that red triangle. And I'm going to redraw it. I think it's always helpful to redraw it with my right angle. My right angle is there at H. And then I have F and I have G. And then we have the blue triangle. I'm going to draw another one. Okay, my right angle again is at H. And then I have E and I have F. Okay, so let's try and get our corresponding parts. So in the big triangle, my right angle here is at F. Okay, and F is listed as the middle vertice. So in the red triangle, my right angle is at H, so that's the middle one. In the red triangle and the big triangle, they both share a common segment G. So they both share that common angle G. I'm totally distracted. So since G is listed second, G goes there. I have to complete it with F. So now my blue triangle. Okay, H is where my right angle is. H is going to correspond to angle F. Again, that's listed as my middle point. E is my common angle. E is listed first, so it goes here. So I have EHF. Okay, altitude geometric mean. I'm going to be saying this a lot. So when I tell you altitude geometric mean, you need to understand what that means. So in a right triangle, the length of the altitude drawn to the hypotenuse, so the length of my altitude is the geometric mean between the lengths of the two segments the altitude divides. So my altitude, CD, is the geometric mean between AD and DB. So notice how I have DB and AD set up. CD is my geometric mean. All you have to do is set up that equation. Now we have the leg geometric mean. Each leg, the length of each leg of the right triangle is the geometric mean between the lengths of the hypotenuse and the segment that the hypotenuse is adjacent to. Okay, so there's a lot going on there. So the length of each leg of a right triangle. So the length of each leg of a right triangle. So CB here is the geometric mean. That's why it's in, I'm going to call it the mean spots. Okay, between the whole hypotenuse and the little piece that's adjacent to that leg. The little piece that's adjacent to the leg here. Okay, so now let's look at the other leg. I have another leg over here. Okay, that leg is the geometric mean, so that's why it's in the mean spots, between the whole hypotenuse and just this little piece of my hypotenuse. Okay, so you need to know both of those equations. Okay, so our next example here. So you have to figure out what we have. Which geometric mean is this? Well, I'm given a leg. So set up your proportion. I'm given a leg. That leg is the geometric mean between the whole hypotenuse and the little piece that's adjacent to it. So 12x is equal to 36, x is going to equal 3. Okay, example 4. Again, we have to figure out what we're given here. So solve for x. Okay, so if I'm solving for x, now notice here, x is the altitude. So I have my altitude geometric mean formula. X and x, that altitude goes in the mean spots between the two pieces of our hypotenuse that we break up. So x squared is equal to 48. I square root 48. Again, I want things in its simplest radical form. That breaks down into 16 times 3, which is 4 root 3. Okay, example 5. Now, what I personally recommend you guys doing is pausing the video now and seeing if you can find C, D, and E if you want. Okay, so that's what I recommend you do personally. Okay, so pause the video now, see if you can find what all of those segment lengths are. I'm gonna start finding all of them. Pause the video. E. I think E, I notice E is the altitude, so E is the geometric mean between 6 and 24. So E squared is equal to 144. E is equal to 12. D. That's my leg geometric mean. So my leg is the geometric mean. So D is the geometric mean between the whole hypotenuse, which is 30, and the little piece that's adjacent to the hypotenuse, which is 6. So D squared is equal to 180. D is equal to the square root of 180. So therefore, D is going to equal 36 times 5. So that is 6 root 5. Again, everything's in simplest radical form. C. Again, another leg geometric mean. C is the geometric mean between my whole hypotenuse and the little piece here that's adjacent to it. And that simplifies to 144 times 5. So that is 12. The 12 breaks out of my radical. 12 root 5. Okay, example 6. Finding the value of the variable. Look again, what type of geometric mean did you have? Here I have an altitude, so it's an altitude geometric mean. So W plus 4 is the geometric mean between the two pieces of my hypotenuse. So when I multiply W plus 4 times W plus 4, that's squared, that equals 144. I square root, and I get technically plus or minus 12 when I square root. Let me do that in red. I square root. When you square root an equation, you have plus or minus. So really I have two equations. W plus 4 equals a positive 12, and W plus 4 equals a negative 12. I subtract 4 over. I subtract 4 over. Okay, we can't have negative values for W because if I were to plug that back in I get a negative side length. So that doesn't work. You always do want to check your values though. Okay, example 8. Mrs. Alspatch is constructing a kite for her son. She has to arrange 2 support rods so that they are perpendicular. The shorter rod is 27 inches long. If she has to place the short rod 7.25 inches from one end of the long rod in order to form 2 right triangles with the kite fabric, what is the length of the long rod? That's a fancy way of saying, what's the length of this? What they want us to recognize is that this is a big right triangle. It's also a kite. So this here is 7.25. This piece here is half of 27, which is 13.5. So I need to find this length. Okay, well, I'm going to name that X. Think about what we have here. Do you have a leg geometric mean, or do you have an altitude geometric mean? I have an altitude because I'm given that 13.5 is the altitude. I'm given one piece of my hypotenuse. I have to find the other one. We solve for X, and I get 25.14. So this piece is 25.14. Let me double check that. That's right. Yes. Okay, and that's rounded. That's when you do that in your calculator, you get a fun decimal. Okay, so I need to now add 7.25 to that 25.14 because I need the length of the whole rod. And I get 32.39 inches. Okay, and that is my video on geometric mean, altitude geometric mean, and leg geometric mean. Thank you for watching.